Welcome everyone. Thank you for joining us today for today's webinar. My name is Sean Wu and I'm your moderator today. Today I'm pleased to have Joy to be here to take us through silicon-proven non-volatile memory and security solution to support the evolution of the modern automotive.
Thank you, Sean. Hello everyone, my name is Joy. And automotive grade eNVM IP is one of the most frequently asked requirement from our customers. So I'm very pleased to be here to share some of our view with all of you.
Thanks, Joy. I know you have prepared quite some stuff to share with the audience today. So I'm going to leave the floor to you now.
Okay.
Thank you all for joining this webinar. You may have noticed that there are more and more exciting developments in electronic vehicles and wondered how embedded non-volatile memory IP can be related to this topic. Today, I will start with the evolution trend of automotive and explain why eMemory's eNVM and security IP are indispensable in this area. Then, in the last section, I will introduce our IP design countermeasures for auto-grade applications. Electronic vehicles have become a popular topic for many years, and we are now quite familiar with electronic systems such as infotainment, ADAS, and even autonomous driving. All these systems are composed of semiconductor chips, from mature node technologies like sensors, drivers, motors to advanced node processors. Among these various types of ICs, embedded non-volatile memories are the critical part to ensure these complicated functions work well. We summarize the automotive technology trends into three aspects. First, cars are getting more intelligent and more connected, therefore requiring higher computing power and real-time response ability. We also know that the electrification of vehicles is a hot topic for semiconductor suppliers, bringing innovations like battery management systems to the market. Last but not least, more security considerations have emerged as huge amount of data now flow across different systems, and the firmware, software, OTA updates has become a must. In the next section, let's see how eMemory's embedded memory IPs can help semiconductor chips to satisfy these new requirements. Here are some specific application scenarios and examples. Cameras and displays are the primary systems of a modern EV relies on to monitor the environment and interact with the human driver. These technologies usually require specialty processes like Hy-V and CIS platforms for sensors and analog drivers, and higher computing power is also required for sensor fusion. eMemory, the leading eNVM IP company, has been striving to provide high-quality, reliable, compact OTP and NTP IP solutions to help IC design houses during the design process. OTP and NTP can be used in the display drivers, touch display integration drivers, non-STDDI, and the image sensors, ISP in the camera modules, to help realize full-time and real-time environment monitoring and vehicle management. As automotive display and cameras need higher resolution and better image qualities, chip manufacturers are migrating their products to more advanced process nodes. eMemory has been working on porting our OTP solutions to these advanced Hy-V, CIS, and logic platforms, providing the widest availability to serve IC design houses worldwide. For advanced SoCs in ADAS, self-driving systems, or ECUs and processors, eMemory's OTP has been used for storing critical information such as pro-analog information like data for SON repair, PVT sensor trimming, or repair and trimming data for chip stacking and advanced packaging. Using OTP for these functions in the SoC can help improve yields and self-baked dies, even improve the performance and reliability of the advanced SoCs. Pro-digital applications like storing patch codes, parameters, and configurations are also popular applications. Of course, our OTP and the content tunneling path technology is an essential part of the security engines in the SoCs, helping end users enjoy the convenience of modern EV technologies with assurance. Software-defined vehicles and OTA are the hot topics in the latest EVs. Due to more complicated system integration, traditional distributed control architecture in the vehicle is no longer suitable for modern EVs. The vehicle computing system is centralized to the architecture shown here, with central control and several zone controllers. If we examine the zone controller, it probably contains components such as an ECU or MCU as the main control, and an Ethernet switch for signal communication and local PMICs. The above-mentioned ICs can use embedded memories such as OTP, NTP, or eFlash for purposes like security, cold storage, and analog trimming. One important thing is that automotive chips can only endure very little delay and latencies. They must react to the environment in real time and cannot compromise any reliability. Standalone NOR flash for MCU ROM code storage, therefore, is working on expanding its data bandwidth, like adding more channels for high-speed data transmission. However, using embedded non-volatile memory is a more reasonable approach for latency concerns, since it largely reduces the data path and eliminates extra components, making the system more compact with faster response. Except OTP and NTP, eMemory also provides new embedded flash IP solution based on zonal technology to satisfy the low latency and the OTA requirements of modern EVs. eMemory's comprehensive IP portfolio can be further enhanced with our path technology and the security IPs, providing the best storage and the security solutions for software-defined vehicles and OTAs. The zonal-based embedded flash technology mentioned in the last page is eMemory's latest breakthrough, NeoFlash. NeoFlash has been developed inside eMemory for years, targeting to be a better embedded flash solution for the MCU market. Since MCU and ECU is the major and important component in electric vehicles, eMemory also makes significant improvements to our NeoFlash solution. Traditionally, MCU designers usually use floating gate eFlash technology or standalone NOR flash as their major storage for ROM code or algorithm. However, these solutions are either expensive or have less ideal form factors. Therefore, eMemory has spent a lot of resources working with leading foundries to develop our novel NeoFlash IP. NeoFlash's performance now is good enough to replace some existing flash solution. Its capacity is expanding to 8 megabits, and our recent development is targeting 16 megabits, and guaranteed endurance up to 100 kilotimes is also aligned with mainstream eFlash solutions. Furthermore, NeoFlash is much easier to integrate into specialty processes like Hy-V and BCD, providing the feasibility of designing a digital-rich high-voltage controller or drivers in more advanced specialty platforms. According to the strict requirements in automotive applications, NeoFlash is also optimized for higher temperature operation, better reliability, and stricter operation and test conditions. We will introduce NeoFlash more in upcoming publications. We hope our customers will notice that NeoFlash is also an ideal eFlash solution for automotive controllers. In the next section, let's see how eNVM can play an important role in power management. PMIC is another essential component in almost every subsystem in electric vehicles, from the simple power converter to complicated PMICs that integrate an MCU inside. eMemory's eNVM IP can store critical data like trim code, ROM code, power sequences, and many configurations of power components. Regarding safety concerns, authenticated power delivery draws attention to charging activities, and the eMemory's OTP and the security IP solutions can hereby contribute to our efforts. A specific example and a hot topic is the battery management system. When we are talking about a large system like BMS, chipsets in this system dividing the work usually need different types of memories. Functions like the main controller, gauge meter and sensors, and charger in a high-end BMS system will require several types of eNVM to store different data and parameters for different purposes. For example, trimming, calibration, lookup table parameters can be stored in OTP or embedded double EEPROM due to their extremely small footprint. For larger amounts of data, like firmware code or status data, NTP or embedded flash can support higher density and endurance for constant updates. Therefore, eMemory, as the industry-leading eNVM IP provider that has the most comprehensive solutions, we are your best partner to have one-stop shop solutions for complicated systems like automotive BMS. This chart summarizes our eNVM IP and applications. eMemory has the most comprehensive eNVM IP portfolio in the industry, covering high endurance and high density to satisfy functions that you can easily find in electronic vehicles. Automotive application is a large system that involves various chips, thus require various types of embedded memories. A highly specialized IP provider like eMemory can help design houses to have qualified IP with widest availability and even customized eNVM IP if needed. In the third section, we will talk about some security considerations for automotive applications. People view modern vehicles as a combination of smartphones and cars. This metaphor describes the fact that modern EVs now hold more sensitive data, such as fingerprints for unlocking cars or address data in the navigation system. All this data should be well protected. Besides, being connected to the internet all the time means not only endpoint but also the back-end server and the whole network environment are exposed to hacking risks. Furthermore, as more software is used in automotive, software authentication work, secure update flow, and version management all need security systems to be involved. From our personal information, V2X communications, to firmware and software OTA updates, these are all important aspects that need a robust and secure environment for modern EVs. Hardware security can be a strong and fundamental infrastructure in every car, especially for the controllers like MCU, ECU, and processors. eMemory and PUF security with our comprehensive security solutions like Secure OTP, PUF-RT, and PUF-CC can help chip designers to have a comprehensive security solution in a convenient, reliable, and cost-effective way. We've also prepared a series of flash protection solutions, either for embedded or standalone flash solutions, to provide wide coverage of hardware security solutions. Here are some brief introduction of our PUF-based security solutions. Based on our anti-fuse OTP NeoFuse and the physical unclonable function NeoPUF, eMemory and PUF security provide fundamental secure OTP IP enclosed OTP, PUF, and anti-tamper features. PUF-RT further integrated features like TRNG, UID, and accessing interfaces as an upgraded root of trust IP solution. PUF-CC further includes crypto accelerators to support secure operations such as secure boot, OTA, and key management. eMemory and PUF Security's PUF-based hardware security IPs provide versatile choices to come up with different security level solutions. A secure OTP IP can be used as a key storage with PUF for the inborn root key. An anti-tamper shell can also help protect the integrity of the encryption keys. PUF-RT and PUF-CC can further support design houses to build up secure boundaries to do secure boot operations and firmware software authorization. Our customers can choose adequate solution levels to fit their requirements from their designs. Finally, let's look into how our auto-grade eNVM IPs can fulfill different functional safety goals based on customers' needs by various design countermeasures. eMemory has different categories of IP design that can help to achieve reliability and functional safety goals. We can help our customers to customize their desired safety levels. The primary requirement of operating temperature can be satisfied through our qualification flows in the foundries. And we can further raise the temperature to 175 Celsius degree for read operation if necessary. For zero failure and functional safety goals, we can add different countermeasures to the IP macro, such as error monitoring and the dual-core lock steps to help our customers achieve more strict product requirements. Here are some specific examples of our functional safety measures. eMemory can help our customers add these features to achieve their desired safety level. Each countermeasure follows the latest version of ISO 26262 suggested safety mechanism for non-volatile memories. For different potential corruptions, for example, ECC and cell redundancy can be added to save data corruption. Address parity can be added to detect address fault. For the analog part of the IP macro, we can monitor the reference current and add a dummy read function to avoid analog corruptions. Other parts of the eNVM functions also have their correspondent countermeasures to guarantee the yield and improve the safety level. IP spec discussion is suggested for eMemory's customers to decide the details of countermeasures to optimize the IP performance and the area footprint. This table shows eMemory's foundry availability of our auto-grade OTP and NTP solutions. For analog-rich applications like PMIC, display driver, and sensors, eMemory has auto-grade OTP NTPs from 0.25 micrometer to 19 nanometer BCD platforms and 55 nanometer Hy-V platforms, contributing our efforts to support more and more specialty technologies. For digital-rich applications like ECU, MCU, MPU, or auto SoC, sensor fusion, etc., eMemory's NeoFuse OTP is available from 0.13 micrometer to advanced nodes including N5, N4P, and N5A, enabling the realization of more intelligent, connected, and secure EVs. If you need more information, please contact eMemory directly and we can have more detailed discussions. Here are the summaries of this webinar. eMemory has comprehensive OTP, NTP, and security IP solutions to support automotive chip makers in conquering the several challenges of smart vehicles, such as ensuring the accuracy of sensors, improving power management, and enhancing connectivity security. eMemory's anti-fuse OTP and path-based security solutions are available from 0.13 micrometer to advanced nodes including N5, N4P, and N5A. Our secure OTP and path-based security IPs are especially helpful to build up a safe driving environment for a modern EV. eMemory's NVM and the derived security IP can meet functional safety standards such as ACLB or ACLD for ISO 26262 and can be customized to fulfill chip makers' requirements.
Thank you, Joy. I think that was a very thought-provoking and insightful presentation you just gave. And it's good to hear that eMemory have a very comprehensive non-volatile memory and security IP solutions that could support the automotive IC nowadays. So again, thank you, Joy, for being here.
No problem. Thank you everyone for participating in this webinar of today, and thank you for your time to be here. And I'm looking forward to share with more information with you next time.